Alright, so continuing here in 5.4 with solving some equations with exponentials and logs. We're on example 6 now. I'm going to solve this equation, and these are the easy equations we went over before because the bases are the same, so don't overthink these. Just solve whatever's inside. So I add 5 to both sides, so I get 4x equals 2x plus 6. Move 2x over there, so I get 2x equals 6, and I divide both sides by 2. So I get x equals 3 as my answer. This one, because it's just a log on one side, to get rid of that 4 there, since it's a base, I have to rewrite this as exponential form. So I put a big 4 here and a big 4 here. So when I do that, I actually have a 4 log 4 cancel out, leaving you with a 5 plus x and a 4 to the third over here. 4 to the third we know is 64. And I just minus 5 on both sides, and I get 59 equals x.
Crazy fool.
Example 8. Alright, before I can do this, I have to kind of smush these together using what we learned about laws of logs in 5.3. So, because there's a 4 out in front, if you remember the rules, I can make that an exponent. So I bump that out in front. So, got to keep that in mind. Okay, so I got to move that 4 up, which I did right there. So I moved that 4 up. And then when you rewrite that, you realize 3 to the 4th is 81. And then because it's addition, according to our laws, I can multiply those together to get 891 over there. And because now the logs have the same base, I just can have 2x plus 3 equals 891. So I just minus 3 to both sides. Those cancel out, so I get 2x equals 888. Divide both sides by 2 to get 444 as your answer.
Jump, Free Willy, jump.
So with this one now, because the logs are the same on this side, and it's addition, I can multiply those two together. And then x times x, when I distribute that through, I get x squared plus 2x. So when I go to rewrite this, that's a 2. I put a big 2 on the bottom because that means those will cancel out. And I end up getting 2 to the third equals the x squared plus 2x. Well, 2 to the third is 8. And because I realize it's a quadratic, I'm going to try to put a negative 8 on that side. So now I'm looking to factor that. Two numbers that multiply to give me negative 8, that add to give me 2 is positive 4 and negative 2. So I separate these and I minus 4 on both sides to get, x equals negative 4 and x equals positive 2. As my answers. So with this one, it works the same with natural logs. You can kind of smush them together because that is division. It's actually subtraction. Or subtraction, that's division on that side. And since that's subtraction, that's division. Since they are both natural logs, I can kind of just pretend like they aren't there and do x plus 6 over 10 equals x minus 1 over 2, and then I can cross multiply to solve. So I get 2 times the quantity of x plus 6 equals 10 times the quantity of x minus 1. And then from there, just distribute those through to get 2x plus 12 equals 10x minus 10. Combine my x's by subtracting a 2x. So I get 12 equals 8x minus 10. Then I can add 10 to both sides to get 22 equals 8x. And then divide both sides by 8, so I get x equals 22 over 8, or 11 over 4.
Who did you expect? Shaquille O'Neal?
Okay, so those are just some more examples. You should have known how to do most of those examples anyway. If you didn't prior, that's okay. But we're going to have some more examples to go over then in a minute.